Hello, this is Sharon from SAS Statistical Programming. In this tutorial, let's look at the normality assumption and the PLOTS option in PROC-GLM procedure. As stated previously, certain assumptions must hold in order for the result of ANOVA to be valid. Assumptions are that observations are randomly selected from independent populations where the residuals are normally distributed and the variance of the outcome variable are equal across those populations. The first assumption dealing with the random selection of observations has more to do with how the study was designed, and analysts can easily assess whether or not some type of randomization process has been incorporated into the study. In terms of independence, the analyst must be confident that the occurrence of numeric values for one population does not affect the probability of occurrence of numeric values in other populations. Consider now the normality assumption. In order to assess the normality of the errors, the analyst can produce diagnostic plots by adding the PLOTS option to the GLM procedure as follows in GLM procedure. Okay. First, we need to get the data set ready. Again, this is the program we used in previous tutorial to create the temporary data set AD from the permanent data set ANOVA_data. Let's run this part of the program to have the data set ready. All right, let's go back to the code window. Now let's look at PROC-GLM. This PROC-GLM is very similar to the previous tutorial, except we include this plots equals diagnostics option to create the diagnostic plots. Okay, so let's run this GLM program and see what we got. All right, this is the output from GLM procedure. We can now focus on the fit diagnostic for a reading score. This is the diagnostic plots generated using that plot equals diagnostic option. Okay. In this diagnostic panel, there are two plots of interest. One is this one. This is the normal quantile plot, as well as this one, the histogram of residuals. So if data originates from a population that is normal, then the points for each observation would fall directly on this reference line. Based upon the visual inspection of this normal quantile plot, we can tell that the points are relatively close to the reference line. The assumption of the normality is reasonable. And also we can look at histogram graph. We can see the arrows are a bit off from the normality distribution. Here we will move forward with the imperfection of the data. In reality, you may choose non-parametric analysis or data transformation to meet the assumption.